Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC 12 Problem of the Week video. And this one is a really advanced casework problem with geometry, parabolas, and using Pythagorean theorem to figure out the solution. So without further ado, let's get on with the video. This is AMC 12A, problem 20 of the year 2021. Suppose that on a parabola with vertex V and a focus F, there exists a point A such that AF is equal to 20 and AV is equal to 21. What is the sum of all possible values of the length FV? And here are your answer choices. So the key words here are that it is a parabola and the vertex is V and there is a focus that is F. And there's going to be a point A that AF is equal to 20 and then AV is equal to 21. It is asking you all the possible values of the length of FV. So if we're trying to find the sum of all of these, first we had to find all the possible values of the length of FV. So firstly, there are two different types of diagrams or possible configurations that can be drawn. So the first one, your vertex is V and then your focus, let's just put it somewhere right here, F. And then it can go down to a point A that is on the parabola, where AV also connects, and that AV is equal to 21 and then AF is equal to 20. And then the second possible way is if it was like, so let's just connect some dots here. So here are the two diagrams being drawn, and I will explain why I did those lines. So first we can see that we are trying to find the length of FV, which is the point from F to V, which is right here. Now I'm going to let this length equal, let's say, and then I let VP also equal A. And then I drew perpendicular lines right here so that VY is perpendicular to XQ, and these two lines are also parallel to each other since this is also perpendicular. And since these lengths are the same, this is also the same length as that. So by definition, we know that AQ is equal to AF is equal to 20. So then we have that AY is equal to 20 minus A, because AQ is 20 and then here is the A, and then so AY will be 20 minus A. And then AX, there's going to be two different scenarios because we don't know whether X is above A or if it's below A, like it's right here. So it is going to be 20 minus 2A, and it's going to be the absolute value of that. Because in this scenario, AX is right here. So this was going to be 2A minus the 20 right here. And in this scenario, it is 20 minus the 2A. So now that we know this, we know that Fx is equal to Vy because this is a rectangle. So we can use the Pythagorean theorem on the triangles FXA and the triangle AVY. And so for the triangle AVY, we get 21 squared, which is AV, minus AY squared, 20 minus A squared, is going to equal VY squared. And since VY squared is also equal to FX squared, we can just put that as this. Now, we know that Fx squared right here, it is also equal to Fa squared, which is 20 squared, minus Ax squared. So these two are actually going to be equal to each other. So when we simplify, we get, and here we can use the equations and then solve for the values of A. And in this case, it is going to be 20 plus and minus the square root of 277 over 3. So basically, both of these values of A are going to work because the smaller solution is going to be with this one right here, and then the larger solution is going to be with the top one. And the question is asking you, what is the possible value of all the sums of FV? So FV can either be 20 plus the square root of 277 over 3 or 20 minus square root of 277 over 3. Now, if we're going to add these together, we get 40 over 3, and that is going to be your answer. So looking at our answer choices, we can see that the answer is going to be B, 40 over 3.